Welcome to the final lesson of this chapter, Events Module Review. In this lesson, we're going to take a look at some of the updates that I made to the Events module behind the scenes. I added some new entities, implemented many more use cases, and I introduced some abstractions that are going to be helpful when we are solving cross-cutting concerns in the next chapter. So let's see what the Events module looks like now. We are going to start our review from the domain layer, and right from the start you can see that I have some new folders for categories and the ticket types entity. But let's open up the events folder and navigate to the event class. If you recall, we left it with pretty much the same properties as you see here, with the exception of a new category ID, because we added the category entity that I'm going to show you in a moment, and I want my event to have a reference to a respective category. Another update that I made was introducing a result type. It's available in the abstractions folder, and if we navigate to the result class, it has an isSuccess and isFailure property, which tells us if this is a success or failure result, obviously. It also has an error object, which is going to allow us to describe what is the error of the current failure result. We have some static methods that are going to help us create a result object, and we also have a generic variant of a result that can contain a value inside. Now, if I go back to my result object, let's take a look at what's changed. For example, I added some validation that the end date cannot be before the start date of the event. And if that is the case, then we are going to return a failure result. All of the errors for a particular entity are documented inside of a respective errors class. So for the event errors, here are all of the errors that I've created. You can see two approaches to defining errors: using a static function that accepts an argument, if I want to create the error description as an interpolated string, or it can be a static value that just describes what is the error. You can see we have some different errors like end date precedes start date, no tickets found, not a draft, already canceled, already started, and so on. If I go back to the event class, you can see that we have the same logic as before. We are also raising the domain event, but I also have many more events here, like publishing an event. This is also going to raise a respective domain event. We can also reschedule it or cancel the event, and all of these actions are going to trigger a new domain event that we can handle inside of our application. Let's briefly take a look at the other entities that we have. So I added the ticket type, which has to be part of a particular event. We have the ticket type name, the price, the currency, and the quantity of how many of these ticket types we can sell. This entity also has a factory method and another method for updating the ticket price and raising the respective domain event. Now, the category entity is very simple. It just contains a name and if the category is archived, which is more of an example, and then we have a few methods inside of this entity. If we move into the application layer, here you will also see a lot of new use cases. In the events feature folder, we have a cancel event use case, create event, and get many events, a use case for publishing and rescheduling an event, and then a use case for searching for published events. We have two use cases returning more than one event or a collection of events, and I did this because I want the get events use case, which returns all of the events from the database, to be available only to administrators. And then on the search events use case, we're going to be looking for only published events. And you can see in the handle method, I'm creating some search events parameters. And this is because I want to be able to filter my events, and I'm also applying pagination. And then we have a query to fetch the current page of the events based on the filter that we are applying. And we also have another query that's going to return the total count of the events for the current filter. Another interesting use case is publishing an event. So let's take a look at the publish event command handler. Here, I'm fetching the event from the repository, checking if it's not null. So this is just simple validation, but then I am making sure that the event that we are trying to publish contains any ticket types. Otherwise, we're going to return a no tickets found error and finish this use case. If all of the validations succeed, we're going to publish this event and persist the changes in the database. This event is going to be particularly interesting when we start implementing communication between our modules and when we also introduce some new modules in the system, because it is this use case that I will use to create a copy of the event and ticket types in the other modules in the system. Another thing you might notice is that the use cases all implement the iCommand handler or the iQuery handler interface. This is because I added some abstractions in the messaging folder for a query or a command type. And this is still using Mediator behind the scenes, which you can see with the iRequest type here. But I'm standardizing my commands and queries to always have to return a result object. This will help me later when I'm implementing validation as a cross-cutting concern, and it's also a good way to standardize how you handle your commands and queries inside your application. The command handlers and the query handlers are just going to implement the respective iRequest handler interface. Another addition that you can see here is the evently exception. We're going to use this whenever we run into a situation that we do not know how to handle. Otherwise, we can just use a result object to return a failure result. In general, I'm against throwing exceptions in the code if you already know how to handle a particular case, but you will see some examples where I think it's appropriate to be throwing exceptions. And we're going to use the evently exception as the base exception type that we are going to be throwing. One more thing that you can see is a clock folder with an iDateTimeProvider interface. This can be useful in some use cases. For example, the cancel event command handler or cancel event use case, where we are checking that the event that we are trying to cancel isn't already in the past, or in other words, that it hasn't already started, because it doesn't make sense to cancel an event that has already started. This use case is quite interesting because if you start thinking about the implications of canceling an event, you will see that it's a much more complicated operation than just updating some fields on the event entity. What happens with all of the orders that were placed for this event, what happens with the customer's payments, and what happens with the tickets that we issued. These are all problems that we are going to solve in the coming lessons. You can see we also have a lot of use cases for the categories entity. So we have the archive, create category, and some querying use cases. And we also have some use cases for our ticket types. Now let me close this down and let's move over into the infrastructure project. Here, I'm adding some new implementations, for example, for the DateTimeProvider, and we are also registering this with dependency injection inside of the events module class. A few more things that you will see is some additional repository interfaces, and other than that, not much has changed. I did make some updates to my database context. It has the categories and the ticket types as database sets, and I also added some entity configurations for my event and ticket type entities, which are placed in the respective folders. So let's take a look at the event configuration. All I'm configuring here is the relationship to the category entity, and then in the ticket type, I'm configuring the relationship with the event entity. This is helpful in our database migrations. So I recreated the original migration because I think it's going to be much simpler, and you can see that we are still using the same schema of events, and then we have a categories table, an events table, and a ticket types table with the respective primary and foreign keys defined. And let's also take a look at any updates to our presentation project. You can see I added a few more feature folders for categories, events, and ticket types. And these folders contain the new endpoints that I introduced for all of the use cases that we have in the system. So the cancel event use case will have a respective endpoint. The endpoints are going to be tagged. So we will have new tags for ticket types and categories so that we can group them together in our OpenAPI schema. And another update that I made, because all of our commands and queries now return a result, is I added some helper methods to help us return different values based on if the result is successful or not. So the result now contains an extension method called match that's going to accept a function that's going to trigger on the success path and on the failure path. There's also an overload when we want to return a concrete result. And you will notice that in case of a failure, for example in the cancel event endpoint, we're going to return an API results of problem instance. And if we take a look at this method, this is a custom type that I added. It's just a static class with a helper method that's going to return a problem details response based on the result object that we pass in. It's going to inspect the error type, which could be validation, problem, not found, or conflict. And it's also going to assign some additional values and include any additional errors which are, for example, present on the validation error type. So this is just going to help us standardize our failure responses from our minimal API endpoints. And I also want to run the application to show you what the Swagger user interface looks like. Here's the Swagger UI for our Evently API project. and you can see that we have the categories, events, and ticket types groups with all of the respective endpoints inside. So we already have quite a few endpoints and quite a few use cases implemented, and we're going to be adding even more in the coming chapters. And now is also a good time to switch over into Postman because I find it easier to test our APIs through Postman. So what you can do is take the Swagger JSON document, which is an open API schema, and you can import this into your Postman file to create a collection of endpoints. And with this, I think we can wrap up the review of the events module. So in this lesson, we reviewed the updates that I made to the events module. I introduced many new abstractions that are going to be helpful in standardizing our CQRS implementation. I also created a lot of use cases for working with the entities that are part of the events module. And most importantly, I created some interesting domain events that are going to be helpful in integrating with the other modules. And all of this we're going to explore in the coming lessons. In the next chapter, we're going to focus on solving module cross-cutting concerns like exception handling, validation, structured logging, dependency injection, configuration of our modules, introducing health checks for any external services, and standardizing how we register our API endpoints.